Hi, my name's Evan. This is me, and this is my dog Snickers. She passed away in September of 2009. But before that happened, during the summer, her and I used to spend nights sitting atop my parents' roof, staring out into outer space and up at the stars. The universe. Getting lost in our thoughts and getting lost in the vast galaxies beyond us. We began to ponder just exactly where we fit into our own blink in time that we may be existing as within this universe. Sometimes it'd get a little bit scary. Kinda cool, right? So we began to wonder, where exactly do we fit in to the context of the creation of our universe over time? If we were to look into context of the universe being created of one calendar year, we would see on January 1st, the creation of the universe as we know it with the Big Bang. And it wasn't until February 7th that our home universe, the Milky Way, began to form. And not 7 months later, on September 3rd, would we have seen the formation of our home planet Earth. And not until the last 5 days of the last month in this context of a calendar year that we see the most common formation and decline of life as we know it, with the dinosaurs rising on December 26th and demise on December 30th. And it wasn't until 5 p.m. on the last day of the last month in the context of this calendar year that we see the formation of early life with early hominids and human life as we know it. And in this understanding, our university students, us alike, were not born until the last 5/100ths of the last second of the last day of the last year. Pretty mind-boggling, isn't it? Though our existence may not seem more than the blink of an eye in the existence of our entire universe and its evolution, and though there may be more stars in the sky than there are individual grains of sand on any beach on the entire planet, the advances in scientific technology that we've made in our brief existence have allowed us to begin to understand and study the evolution of the universe as we know it. In particular, in a study released in an article to NASA's page, that using the Spitzer telescope, 2 University of Arizona astronomers, as a part of the Sloan Digital Sky Survey, had discovered 2 of the most primitive black holes amongst a study of 21 quasars. Black holes are enormous distortions of space and time. They usually lurk at the core of galaxies, and these supermassive black holes are usually called quasars, with a mass in the center of over 100 million suns. It's an understanding now, in comparison to our early universe, that the universe as we know it is quite messy. As it began, the current dust that may be the planets and asteroids that we know would have never existed. The 2 primitive quasars that were discovered are located over 13 billion light years away. They were classified against the other 19 quasars discovered by their lack of dust. As quasars begin to grow, they begin to swallow all of the mass surrounding them into their center. These early quasars were located because of their lack of dust around them, initially locating them by their primitive being because of their lack of emission of light, which occurs as the consumption of dust occurs. So what exactly is it that makes these 2 quasars, J005006 and J0303-00, so unique? According to this artist's rendition, we can see at the center, the dot, the enormous black hole, surrounded by the rings of outward gas. And notice that there is a huge, enormous lack of dust, which would have then been consumed to form the massive amounts of light that we see in other familiar quasars. As the drawing shows, these gas swirls create the accretion disk, which we're familiar with through the nebular theory, which we'll discuss later. The donut-like shape and dusty structure are called the dust torus, shown in the image to the right. That on the top represents that of J0506 and J303. Notice on the bottom half of the graph on the right, the creation of a dust torus in a more advanced evolution of what would be these black holes beyond their primitive state. So what exactly does the discovery of these two primitive black holes do for the human race in the understanding of the evolution of the universe as we know it? The two images of the primitive quasars are them in their original appearance over 13 billion light years away. Seeing that a light year is the measure of distance that light can travel in 1 year, this is actually the appearance of these primitive black holes over 13 billion light years ago. The primitive quasars, hopefully, by understanding and discovering and studying these images, will provide a better understanding of the roots of our universe and how perhaps even our universe our galaxy began to form. The edge of the galaxy as we know it is over 15 billion light years away. By understanding that these images are 13 billion light years away, this allows for us to realize that these creations of these primitive black holes occurred within the first 2 billion light years of the existence of the universe. By studying these, we can understand and begin to confirm some of the earliest theories of what it is that we came to know the understanding of the universe and how it came to be. So how to relate it all to what we've studied together? By capturing and understanding these images, it can partake in understanding the nebular theory that we began to look into prior to our midterm exam. The black holes represent an undiscovered stage in the evolution of the universe. Prior to these pictures being taken, it was only an assumption that the universe was dust-free and as clean as was to be understood. The nebular theory occurs in a matter of 4 stages. The first being contraction, where clouds heat, flatten, and spin fast, and become a spinning mass of dust and gas. This evolutionizing into condensation, where hydrogen and helium, while remaining gaseous, begin to condense into solid seeds and begin to form planets. The accretion stage, which we see in the images of these modern black holes, create solid seeds, collide, which stick together with larger ones and attract with their gravity and still grow bigger. Past this, we don't see any existence of images like this and understanding of other galaxies in the universe that are similar to the images that we see. These two quasars can help us to understand the universality of the composition of our universe.